Okay, this is the question we have. Now we are seeing examples, and this is going to be the first example about our jointed rods. They are very easy, as you can see. Two uniform rods. The moment you hear the word uniform, it means that the weight is acting in the middle, or the center of gravity is acting in the middle. A, B, and C of masses, 4 kilograms and 60 kilograms, are hinged at B. So they are doing this, that they are hinged at B there, and rest in the vertical position on a smooth floor, and A and C are connected by a rope. So this is this A and C, they are connected by the rope. But remember, these two here, they are resting on the floor, but they are doing it by a rope. So if they are resting on the floor, it means that we are going to expect some reaction. So find the reactions between the rope, the rods and the floor at A and C when the rope is taut. Taut means that you cannot extend that rope. It means that it's very fixed. So now these two, A and C, are resting on the floor, although they are joined by a rope. So because there is contact between this A and this C and the floor, first of all, we expect reactions. So we are going to be having a reaction at A because there is contact between this A and the floor. We're also going to expect a reaction at C, which we are calling RC. That is the first thing. Now, they told us that this and this are uniform rods of weight AB, 4 kilograms. So it means that this AB is going to be acting in the middle. So it's going to be acting in the middle in this order, as you see there. So this is going to be my weight. Net weight, we get the mass times B. Then also here, we are going to be having, this is going to be our middle part. So there, we are having now 6 times G. Now, these are the basic. This is the middle part, and this is the middle part of this AB and AB. Because they were uniform, we only do this if they are uniform. Now, the length from here to here was 4. It means that this one is going to divide this into 2. So this one is going to be 2 meters, and this one is going to be 2 meters also. So I will add this and this and this to get back to our 4. Whenever this rod is uniform, this weight is going to divide this into 2 equal parts. The same here. This was 8 meters, so this is going to be 4 meters, and this is going to be 4 meters. As simple as that. So whenever this one is dividing this in the middle, it means that also from here up to here, it's going to divide also this horizontal line into 2 equal parts. Okay, those are the first cases. Now, you know this string was connecting these two. It means that it has tension in it. So meaning this tension, remember, is connecting this, meaning there is force pulling this side and there's a force pulling this side that it's connected. So here I'm going to have our tension T, and also we shall be having our tension T in that string. Simple. Okay, so basically we have, I think, finished putting all we did into that. So what do we do? They want us to find the reactions at B. You said when you want to get reactions at either A or C, you get moments. So if I want to get the reaction at C, I take moments at A. If I want to get the reaction at A, I take moments at C. Or you can take moments at A and you get the reaction at C, then you post that for resolving, and then you get the other moment. So basically now, you see, let me take moments at A so that I can get this reaction at C. So when you take moments, you see C is going upwards, so let us say, now this means I'm taking moments at A, but anti-clockwise. Now, you see, forces acting anti-clockwise from here, we have only this one going up. I think this is anti-clockwise. We say moments are given by the force times the computer distance from a point where I take moments from. So I take moments at A. So now it means that the force, first of all, which is acting anti-clockwise, is RC. So our reaction at C times the perpendicular distance from A. So from here up to here, I think we see we are going to be having 2 plus 2 plus 4 plus that, which is going to give us, I think we are going to get 12. It's the only thing that is acting anti-clockwise. Now, if you take moments at A, all the forces from A, their moments are going to be zero. That's why this moment for this force is going to be zero, and then the moments from this is going to be zero. Why? because the perpendicular distance these two forces from A is 0. So that's why we shall say RA times 0 because the perpendicular distance is 0 and also this time is 0 as 0. Even this is coming to A, so this perpendicular distance is going to be 0. So, and clockwise, then we use the that the principle of moment, it says the sum of clockwise moments is equal to the sum of anti-clockwise moments. So we have all of this in the anti-clockwise. Now we have this in the anti-clockwise and this in the anti-clockwise. So this is going to be now. You see now, when I get my 4G, I think you see for it, it's going to be acting clockwise. So clockwise from A, I have now 4B times the perpendicular distance from A to this force. I think you see it's going to be 2. Then plus, also this force is acting clockwise. I think you see. So 6B, then times the perpendicular distance from A. We have this, which is going to be 8. And so there you can set our RC is going to be, this is going to be now 8 times 9.8, then plus 8 times 4, that is, 8 times 6, that is 48 times B, which is 9.8. Then we divide by 12. And so our RC here is going to be, I think you can look at my answer there. So my answer is 45.733 newtons. That's the reaction at C. Now, you see that I got the reaction at C after taking their moments at A. Now, if I want moments at A, I take if I want reaction at A, I take moments at C. Let us take moments at C. Now, it's that this one is going to act clockwise. You can even act anti-clockwise, no problem. But you see that this force is going to act clockwise. So this means that I'm taking them clockwise. So clockwise, I think you can see this is going to be going in that direction like that from C. I think you see this force clockwise. So I have first of all RA, then times the perpendicular distance of this from C. I think we are going to add these ones. It's going to be 12 equaling 2. Now these ones, I think you see from C, now this force is going to act anti-clockwise, and this one is also going to act anti-clockwise. So I have first of all 4B times, you see 4B is there. From C, we add this, and this, which is going to give us, I think you see, when I add it from here, I add this 2, plus this 4, plus this, I'll be adding 10. Then plus, now you see this 6 is going also clockwise. I get 6B, then times from C, because I'm taking the perpendicular distance from here up to here is 4. Why is it perpendicular? Because you see this is perpendicular there. So from here, my RA is going to be, this is 40 times B, 9.8, plus this is going to be 24 times 9.8 to the whole, divided by this 12 here. And so my RA is going to be, okay. I think you can see the force I'm getting. So the reaction at A here is 52.266, then 7. These are going to be also newtons. So that's our reaction at A. Really easy, nothing to say. Then part B, they're telling us that this is our part A. Then part B, they're telling us that if a body is attached a quarter of the way up, CB, and reactions are equal, find the mass of the body attached. So I'm going to draw another diagram here for that part B. So they are going to allow me, and I pause then and after that diagram. Okay, so now I'm done with drawing that diagram. So I'm just drawing this to this. Now we come. They're telling us that if the body is attached a quarter of the way up CB, a quarter of the way up CB, so a quarter, remember, this is halfway because this weight was divided this into equal parts. So if this is halfway and this is halfway, then a quarter is going to be halfway of this halfway. So means that now we are touching the mass here of m kilograms. So we say this is going to be m, then times d. Now remember, from here up to here was 4. So if this one is divided into 2, then this is going to be 2 meters, then this is going to be 2 meters. Our attention is there. Now, of the upward CD and reactions are equal. So it means that now, here the reactions are going to be equal. That's the condition they are putting. So this reaction is going to be R. If this is R, then here reaction also is going to be R. Not this. Whenever you add a force on a rod, the reaction is here going to change. So that's why here the reactions are equal. Not that in all of this they are going to be equal. No. Just this question is telling us that they are going to be equal. So basically that's what we have. So if they are equal, now what do we do? You see we need this R, we need this. These are the only unknowns we have. How are they positions? These are positions vertically up, and this one is a position vertically downwards. So meaning the first case we are going to resolve vertically. So resolve vertically, it means that now I'm going to be having those going up. I have R plus R. I think those are the only forces going upwards. So then downwards I have 4G, then plus 6G, then plus MD. So this one is going to be 2R equaling 2. You see what's common there? This is going to give us 10. So that G is common, which I can every factorize. I have 10, then plus M, they all into B. I call this one equation 1. So the other one saying to get moments, you take, to get moments, to get the reaction here, you either take moments here or you take moments here. So either way, either you take moments here or you take moments here, it is okay. It's going to be the same. Let me get started, I can show you. Okay, so now I'm going to take moments. You can take them here or here. So I choose what? Okay, let me choose A. So taking moments at A. I'm going now to take them because I want to get these ones. So let me take them from A. I think we start this one is going anti-clockwise. So let me take them anti-clockwise. So taking them anti-clockwise, we start now my R times the computer distance from A. Here we have, I think we are going to be having our 12. When you add all these ones, you get 12. I think that's the only anti-clockwise. Because we said where I take moments, the forces from there are coming to or from this point where I take moments, their moments are going to be 0. So that's why this force I don't consider it. Because this one is coming also to A, this one is from A, this one is from A, I don't consider this. I only consider these ones. So it's going to be equaling to, so the only forces surviving this, and this. So it's now from A. If I consider this, you see from A, it's vertical. This force is vertical, so it's probably this is going to be horizontal. So I'll be having 4G times 2, then plus. This one is going to be 6G, then times from A. This is 2, that is going to be 8. Then plus MD. This family, this is from A, 2, this is going to be now 8 plus 2, that's going to be 10. So from here, I can every get my R, and then I can every substitute it there. So from here, so I can get my R, or if I divide through by 6. So then we combine, so it's that my R from here is going to be, this is going to be 8G plus, this is going to be 48G. This one is going to be 10mg. The whole divided by 12. The whole divided by 12. So as simple as that. So you see here we can reduce by 2 throughout. Then we put our R into there. So making R the subject here, then I'm going to put it in here. To start now, I call this equation 2. Now I say put 2 in 1. Or we can divide it here by 2. So that here our R is going to be equal to 10 plus M B over 2. When I put it there. no problem. So from here, you can start now. This one is going to be equaling to that one. So I said this is going to be 10 plus m into d, the whole over 2 is going to be equaling to. So now here 8d is common, d is common. I factorize out this d. Here we are having this part, this I have 56 plus 10m, the whole over 12. So that this is going to cancel by this one. By this I'm going to be having 6. And then cross multiply here. I have 6 into 10 plus m equaling to 56. Then plus 10m. So can you open brackets? So here we have 60 plus 6m equaling 56 plus 10m. So take this side. I'll be having 60 minus 56 equaling to 10m minus 6m. You see from here, I'm going to be having 4 equaling 4m, implying that now my m is equaling to 1. So it implies that the weight we had to put there was 1 kilogram. As simple as that. So, if they wanted you to get the reaction, then you now put here 1 divided by 10 simplify. So, that's how you had that question. I wish you will. I think you see, they are very easy once you know the basics. See you in the next lesson.